So that's graphing sine, cosine, tangent, secant, or cosecant, secant, and cotangent. And that'll just be like one full cycle, so they'll just look like the graphs that we did. They're not in this set of notes, but anyways, they'll look like the graphs that we did the other day. So just make sure that you have those in your brain for tomorrow. There'll be 5 points each, so it'll be a total of 30 points. Things that I'm looking for are that they're labeled correctly, that they start in the right spot, obviously, like the graph itself looks like it's supposed to, and that you've done one full cycle. So, any questions about that? All right. So, jumping in here. I think we had finished up the notes the other day. Yeah, we did. So just as a refresher, the first thing that we're going to do when we're graphing either sine or cosine, we don't do this for any other one, but just sine and cosine. We look at the a value, so the number in front of our trig function that's directly touching it, and the amplitude is the absolute value of that. And so that's like how high it's going to go. Obviously, if it gets shifted, our graph may go up more or down more, but that's where like the baseline function would be. And then we find the period, which would give us one full cycle, and we take 2 pi and we divide it by b, which is the number in front of x. Sometimes that b will be in front of the parentheses, sometimes it's just directly in front of the x. Either way, it's fine. And it would be 2 pi over b. Again, technically it's absolute value, but I don't ever see a b value that's negative. It causes some entirely other problem. And then we take whatever our period is, we divide it by 4, which gives us our scaling, so we can count on the x-axis and scale them. The value inside the parentheses, where it's like plus or minus and then some number, that tells us if we're moving left or right, and it's opposite the direction of the sign. So if it's positive, we're going left. If it's negative, we're going to the right. And then outside the parentheses, where we had that plus or minus d value, that tells us if we're going up or down. And that goes the same direction as the sign. So positive is up, negative is down. And then finally, we determine if the graph has been reflected or not. And so if A is negative, it's been reflected over the x-axis, and so it just takes the whole graph and flips it upside down. So if a value was at, let's say, 0, 1, then that value is now at 0, negative 1. So it just flips it over. So, jumping into some problems here. And we're not going to do like a ton of them. This is just an intro so that if you take pre-cal next year, you're not seeing it for the first time. Really what it boils down to. There may be some problems when we actually get to the quiz or the test. Probably the quiz will be on Friday, I would say, where we're looking at like 6.3 to 6.6. And when we do that, some of them may tell you to graph them. Some of them may actually say, just state all the things that would be happening. And so basically you just do steps 1 through 6 without the actual graph at the end. So just be aware of that as well. And we'll do that on a couple too here. So let's see, just jumping right in. I'm in 6.3 right now, just for reference for problems, since we've kind of been all over the place with these things. So this is 6.3, page 601 is where we're starting out. So if I jump to something in like 6.4 or whatever, we will do that. So these first ones, it says to graph, but all we're going to do for problems 23 through 40, which is all we're going to do out of 6.3, and then we're going to jump to 6.4. I'm just going to do a few of these ones here. They just want us to state the amplitude and period. Don't graph. So they say to graph, but again, they do their stuff in sections. So 6.3 is just the baseline. The graph has not shifted or anything. But when we go to 6.4, we will be doing that and we will be graphing. So These ones aren't going anywhere other than just having an amplitude and period. So even though the instructions say to graph, we are not graphing these ones. So let's see. Let's start out with 24. So 24 is y equals the sine of 2/3 x. So my amplitude is whatever number is in front of sine. In this case, there's just a 1. So my amplitude is 1. Then the period is 2 pi over b. So that would be 2 pi over, in this case, this is a fraction, so 2/3. At this point, I would need to keep change flip. So I would have 2 pi times 3 over 2. 2's here will cancel, and so my period would be 3 pi. And so that's all we have to do on this little section of problems here. Let's see. And just as a refresher, where does the sine graph start?
0.
Yep, at 0. So if we were graphing this, we would be starting at 0, but we're not graphing this one. Let's see, 30. Y equals 3 sine of 2x. And just a reminder, if these change to cosine, it wouldn't change anything about the amplitude and period. It just changes where the graph starts. So, I feel like this is really blurry. All right, so what would the amplitude be here for number 30? Yep, 3. Then my period is 2 pi over this number, so over 2, which just reduces to pi. Let's see, 34. Y equals negative sine of pi x. So what would my amplitude be for this one?
-1.
Just 1, because amplitude has to be positive, so it would be 1. What would that negative in front be telling me? Yep. So the negative tells me that it's reflected, so I'm just going to note that here. Again, you don't have to do that with these ones, but just so that we're starting to get aware of that. And then the period is 2 pi over pi. The period is just 2 in this case. So obviously, typically the ones that we've done, period has had a pi in front of it. In this case, it does not. Let's see, one more of these ones, and then we'll jump to the next section. 36. Y equals 3 cosine of 2 pi x. So what's the amplitude here? 3. And period? You can tell me how to write it first if you want. 2 pi over 2 pi, and so what does that leave me with? 1. So where would, if we were graphing this one, where would this graph start at? Where does cosine start?
0.
Nope. Sine starts at 0.
1.
Nope.
Which one?
Cosine. I'm not talking about the parent function. I'm talking about this problem.
Oh. 3.
The parent function does start at 1. Yes, this one would start at 3 because that's the amplitude. Cosine always starts at our amplitude value. All right, any questions on those ones? All right, so that's all out of 6.3. Again, on those ones, we're not graphing. All you're doing is stating the amplitude and period. I'm only going to give you a couple of those. While we're here, I'm going to go ahead and tell you what those problems are from 6.3, and then we're going to jump to 6.4 and do a few that we're actually graphing, like I said, not a ton, just a couple kind of easier ones to make sure we know what we're doing. So here, let's do 26. Oh wait, not 26. That's one. 25. There we go. I was like, not an even one. 29 and 35. So just those three out of that section.
Can I go to my locker room?
And let's see if I can flip the pages in my book here. All right, so then now in 6.4, page 613 and 614, we may end up on 614, I don't know yet, but anyways, that's the two pages that we'll be looking at for 6.4. Again, these are going to be some modified instructions, just ever so slightly here. So in this one, they want us to do, we're going to state amplitude, period, shifts, reflections, and then we're going to graph one cycle. Okay, so most of the problems in this section say to graph 2 cycles, we just need 1. Okay, so anytime it's asking you for 2, you can just do 1. That's totally fine. If you can do 1, you can do 2. There's really no difference there, because it just keeps repeating over and over and over again. So, that being said, let's jump right in here. And I guess I should specify, these are technically problems 29 through 36. That this is for. We may do the same thing on a couple problems that are in here later on, but for right now, that's where I'm at. So 30, y equals 3 sine of x plus pi over 2, and that's in parentheses there because that's important. So my steps here in order, so I'm going to do the steps over here and like getting all the information written out, and then I'll do my graph over here on the right side so we can keep everything straight. Totally up to you how you want to do it. But so step 1 is to find the amplitude. So what's the amplitude of this graph? 3. Step 2, and you don't have to write like step 1, step 2. I'm just doing that for this first one, and then after that I won't write it like this. What is the period?
1.
It's the formula for finding period.
2 pi over b.
2 pi over b. What is b? I think that might be what you were trying to tell me. Yeah, that's 1. So that means the period, though, is 2 pi. Okay, so always remember, just because there's not a number written there doesn't mean there's not an imaginary 1 sitting there. Okay, some people get confused and then are like, there's not 1. I'm like, there has to be 1. Anyways. Step 3 is finding our scale. And so remember, that's the period divided by 4. So in this case, it'll be 2 pi divided by 4, which will reduce to pi over 2. Then, is this moving left or right? Left, because it is a positive, so this is going left, pi over 2. Is this one going up or down? Neither. So step 5. And again, normally if it doesn't do this, I wouldn't write anything. But there's no shift up or down is what, if I am going to write it out, this is what I would say. But you don't have to write that normally. And then is this graph being reflected? No. So step 6, not reflected. And again, I just wrote out all 6 steps so that we could see it for reference. But you would not have to actually write out everything. I usually only write out what actually is happening, not the stuff that's not relevant. So I'm going to set up a graph over here. So when I do this, I always am going to look at the period and say, okay, I know I'm going out to 2 pi, so I'm going to set up basically 4 little tick marks here. The end one is going to be whatever the period is, so in this case it's 2 pi. My scale tells me what each tick mark is leading up to that. So the first one would be pi over 2. The next one will be 2 pi over 2, which reduces to pi. Then 3 pi over 2. And then, not 4. And then if I kept going, 4 pi over 2 reduces to 2 pi, which is where I need to get to. Now, if this graph was not shifted left or right, I wouldn't need to put any more values on here. If I know it's going to the right, I would need to add some more over here. I know this graph is going to the left, and that's why I write out all this information first. Then over here, I need to go to negative pi over 2. Because if I have a value starting here at 0, then I know I'm going to go left 1 spot, which in this case is pi over 2. Now, there are times where it's possible this could have gone left pi. Then I would have needed to add 2 spots because everything's going left 2 spots. Okay? And then the amplitude is 3, so I'm going to put 3 little marks here on top and bottom because that's where that's going to. Again, if it was shifted up or down, I may need to add some more above or below. But that's not happening, so I'm good to go. So earlier we said sine starts at 0. So the first thing I will always do is graph this as if there are no shifts happening at all. Okay, so if this was just these first 3 steps and nothing else, I will always graph it that way first. So it starts at 0. Then at the next stop or at the next point, it's up at the amplitude, so 3. Then it comes back down to pi, or well, back to 0, I guess, at pi. And then over here, it keeps coming down. So at 3 pi over 2, it's at negative 3. And then at 2 pi, we're back to 0. Okay, so this graph then would look like this to give us our 1 full cycle. But that's only up through that part there. So now if any shifts are happening, if the graph is reflected at this point, I would do the reflection. Sometimes I start out with the reflection just so that there's like less graphs happening because people tend to get confused, but it's up to you. But now I know this is going left pi over 2. If it was also going up or down, I would do all of this in one step. But left pi over 2, I take every point and I shift it to the left 1 spot. So this one here moves to right here. This point moves here. This point moves here. This one goes here. And this one goes here. And so now, same graph except for it's been shifted over. And so I always will put, if I'm doing it in colors, I make sure that I label what that is. If you're just using pencil, or even if you're using colors and you're not like marking out what things are, and sometimes we end up with 3 or 4 graphs depending on how you do your shifts, I always want you to tell me which one is your final if there's more than one on there. Okay, if this one wasn't being shifted or anything like that, and there was only one graph on here and that's the final graph, obviously we don't need to write the word final. But I want to make it clear that the graph that I have in red is my final graph so that when I'm checking, I can just look at that one. I don't have to look at every single other one if this one is right. Okay, I'm not sitting there guessing which one you think is supposed to be the right graph. Any questions about that? And I know this is very different, obviously, than graphing you've done before, so it's going to take a little bit, but that's why I'm giving you the intro this year. So if you end up in pre-cal next year, you're not like flying blind, because it's a lot harder the first time you see it than the second time around. All right, 32, y equals negative 1/2 sine of 1/2 x plus pi. Again, that's in parentheses there. All right, so first and foremost, what is my amplitude here?
1/2.
Yep, 1/2. And when I go to put this on my graph, I'm going to probably not put it, like super tight to the x-axis. I'm going to move it accordingly. So even though it's only 1/2, I'm going to, give it some space. Anyways, what about period? 2 pi over 1/2, which when we keep change flip would give me 4 pi. So then scale, if I can spell, we take 4 pi and we divide that by 4. So in this case, I'm counting by pi's, which is nice. What else is happening to this graph? Basically doing steps 4 through 6 here. It's reflected. What else? What is this plus pi in here telling me I'm doing?
Going left.
Yep, left pi. And so obviously technically in our steps, reflected would be step 6. It does not matter. I actually would highly recommend that you reflect the graph before you shift the graph, because I've seen so many times where you get like the person like doing it will get the shifting right, but then when they reflect it, they get that part wrong. But if you reflect first, it's a lot easier to shift versus shift and then try to get it reflected where it's supposed to be and all of that. So I reflect first, but it's up to you. For the sake of it being the first time that we've had a reflected one, I'm going to actually do this. I made that way too big. I'm going to do this truly step by step. As like basically I'm going to have 3 separate graphs on here this time. So I'm going to put on period goes out to 4 pi. I'm in increments of pi. So I've got pi, 2 pi, 3 pi. I know I'm going to be going left pi, so I'm going to go ahead and put a negative pi on here. Then my amplitude is 1/2, so like I said, I'm just going to make sure that I'm noting here. If you're counting by ones, we don't have to necessarily write it on here. Not being a great example, I probably should have at least written where the max point was going, but anyways. More important if it's not increments of 1 that you're counting by. Sometimes we count by 2s, or obviously in this case 1/2. Now, I could have put a 1 on there and then I could have just gone halfway between, but I might as well just do 1/2. It's not going anywhere. So, first of all, I'm just going to do the baseline function with absolutely nothing happening to it, just it being this part of the graph here, okay, where it's just the amplitude and period, no reflection, no shift yet. So, sine starts at 0, then it goes up. We start coming back down, down again, and back up. And so this would be the baseline graph for this one. Now again, I would reflect first. So we take it and it's flipping over the x-axis. Okay, so any point on the axis is going to stay exactly where it is. They aren't moving, right? Because if I take this and I flip it over, they stay right where they are. The only thing where something different is happening are these ones that are off. So this point that's up here at 1/2 is now at negative 1/2. like a mirror. And this point that's down here at -1/2 is now at +1/2. And so coming down, up, and back down. So my red is my reflected graph. Then green is going to be my left shift. So now I take every one of these red points and I move it to the left. So here, 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 and here. And so then my green is my final. And that's still one full cycle because it starts here and it ends up back there at the end. And so I'm just going to point here that my green is my final. Questions on that? These kind of making sense a little bit. It takes, we'll probably do 2 more together, and then I'll give you like 3 or 4 to do on your own, like these for practice, and then we'll go over them probably Wednesday, because tomorrow I'm going to give you time to work because I don't think you're going to have enough time today to work. And I want to make sure that we get this stuff down. 3 looks really weird. All right. Y equals negative cosine, and then they're using a bracket here to do the pi times x minus 1/3. Actually, want to check on one thing real quick. Because some books write this differently, and I just want to confirm something. What is it? 6.4. Just wanted to confirm. So this pi that's here in front is what our b value is. It just looks different because it's not directly touching the x, but sometimes they write it that way. That's what I just wanted to confirm, that that was really what they were doing here with these problems. So anyways, first thing is amplitude. So what is the amplitude of this cosine graph? 1. Period would be what?
2 pi over 1, or 2 pi over pi.
Yep, 2 pi over pi, which would then give me just 2. So notice this one's different in that it's not like increments of pi that we'll be counting by. It just doesn't change anything other than scaling itself. Scale would be what?
1/2.
Yep. 2 over 4, which would be 1/2. And then what else is happening to this graph? It's reflected, and what else? Yep, right 1/3. Now, I'm going to tell you, obviously, being that I'm scaling by 1/2 and it's going right 1/3, there's going to be a little bit of a guessing game. It's not going to be going right quite one full spot. I'm not going to get out a ruler and measure, but we know that 1/3 is less than 1/2, right? So I don't need to go quite one whole spot over when I'm moving my graph over. It's going to go over like 2/3 of the way or something like that. We're just going to be an approximate, and that's okay. All right, nothing else happening to this graph. We've covered everything, so I'm going to set it up over here. Since this is the first cosine one that we've done, I'm not going to do all the reflection in the one step. I'm going to do it in separate steps. All right, so amplitude of 1, so I'm going to just, well, maybe put that here. And then I'm going out to 2 increments of 1/2. So 1/2, 1, 3 halves, and 2. And then I know that it's going right 1/3, so I'm going to go ahead and go over here and go to 5/2, just so that I have enough room to do that on my graph as well. So where does a cosine graph start? 1. In this, obviously in this case, it normally would be whatever the amplitude is, which our amplitude is 1. So again, baseline graph here, I'm going to do in blue. So I start up here at 1, and cosine makes a V. Okay, that's 1 full cycle as it makes a V. So it comes down, goes down again, and then it comes back up, and it loops around. Well, if I can connect the dots. Close enough. So that's the baseline graph with nothing happening to it. Again, I'll reiterate, I would reflect first so that we don't get confused by it being shifted. It's more of an issue when the graph is shifted up or down that people tend to get it wrong, not so much right and left, but I still would say just get in the habit of reflecting first before we ever shift left, right, up, or down. So these points that are on the x-axis stay, because remember, if we take them and we mirror them, they stay in the exact same spot. Point at 1 goes down to -1. Point at -1 goes up to +1. And then again, this point that's at 1 goes down here to -1. And so now, instead of looking like a V, whoa. I don't know what just happened right there. Glitch in the iPad, I guess. It looks like a little mountain. Now at this point, I take all of my points and I shift it right 1/3. Again, since that's just a little bit less than 1/2, I can basically go, I guess it's technically what, like 3/5 of the way. But anyways, I'm not going to get out a ruler and check, but I do want to show that it is shifting to the right ever so slightly at every point. So I'm taking all these red points and shifting them over just a little bit. And it doesn't have to be perfect. This is just an eyeballed graph there. But again, I've got a lot happening, so I'm going to make sure I'm noting here that this is my final graph here. Forgot to mark my colors here. If you want to use colors, absolutely fine. If you're like, nah, I'd rather do pencil because I know I'm inclined to make a mistake, that's fine. Just label which one's your final. The stuff in between, you don't really need to label. I'm just doing that in case you're going back and looking, seeing what I did. So, questions on that one? All right, then very last one. Y equals -1 plus 1/2 cosine in parentheses 2x minus 3 pi. So a lot more happening in this graph, okay? Now, this one is different. Well, let me see. It's different. What do you notice is different about this graph? Or like this compared to the other ones?
There's 2 a functions.
Okay, so there's 2 things in front of cosine. Only one of them is actually a, but yes. So, amplitude is always the number that is directly touching our trig function. Okay? This other number out here is actually my shift up and down. For some reason, it appears that in your book, they have put the plus or minus d part of our original equations that we had way up here in front of a. I don't know why, because in pre-cal they don't do that, and it's the same person that made the textbook, but it appears that in almost every situation they put that value in front, okay? Which is good, because I tend to trip people up with this in pre-cal when I flip it, because sometimes. I think there's one problem in their book that's flipped, and they have to pay attention to it. What I would do is I would rewrite this in the order that we had in all of those, the notes, okay? So I would rewrite this as y equals 1/2 cosine, and obviously if this was negative, we would need to keep the negative with it, but it's positive in this case. 2x minus 3 pi, and then over here, minus 1. So that now I'm in the form a cosine of bx, in this case it's minus c minus d, so that it looks like what I'm used to, okay? I may sometimes, if I on the quiz or the test, I may put it at the end. I may leave it in front so that you have to pay attention to where it's going. But know that whatever number directly touches the trig function is the amplitude. Any other numbers out front are the shift up and down, okay? So in this case, then amplitude is 1/2. Period would be what? 2 pi over 2, which just gives me pi. So then scale, what would be the scale on this one?
Pi over 4.
Pi over 4. What else is happening to this graph?
It's getting shifted down.
It is going down. Down 1. What else?
It's getting shifted right 3 pi.
Yep, right, 3 pi. So that's going to be pretty crazy, okay, because my period is pi, but my scale is pi over 4. So that means it's going to be going way out, right? So when I set up this graph, okay, I always visually, mentally, whatever, think about what is this graph going to look like, okay? If I'm only, my period's out to pi, but every point has to be shifted to 3 pi, or 3 pi to the right, then I know I've got to have a lot of extra space on that side. So this graph, I'm going to actually pull, since nothing's going to the left, I'm going to pull my whole graph here over, and so that I have plenty of space here. So what I'm going to do then is I'm going to put amplitude of 1/2. So what I'm actually going to do is I'm going to count 1/2, or increments of 1/2 here. Do the easy part first, do the y-axis. Now, I know that it's going down 1, so if I have a point at negative 1/2, then I need to be able to go to negative 3/2. And again, I try to pick whole numbers when I'm doing it for you on a quiz or a test, just so that it's not anything crazy. But on my y, I need to go down to negative 3/2 so I can shift everything down one spot. Okay. Now, the x-axis is where it gets a little crazier. I know that period is 4 pi. If I'm going to go 3 pi to the right, I add 3 pi to that. That means I'm going to ultimately be all the way out here to 4 pi. Okay. Half of that would be 2 pi. Half of that is pi, which you may want to note that this is where the period is so that you know that you've got one full cycle in there, just so that you have it for reference. It's up to you since this one's going so far over. And then halfway between here is 3 pi. And then since it's increments of pi over 4, I'm going to break each of these little sections up into into sections. So I'll have pi over 4, pi over 2, 3 pi over 4. Now, in these other sections, I'm just going to put the tick marks. I'm not going to sit here and count them out. You're welcome to count them out if you want to, but I'm just going to put the tick marks on here so that I know where this stuff is happening, so I can make sure that I get everything shifted where it needs to be. So in your first cycle, you need to have it labeled. After that, you can just put the tick marks on there because it's getting a little crazy. Oh, the sun's coming out. That's exciting. It's been very rainy. All right, so cosine starts at the amplitude. The amplitude is 1/2. So at 0, 1/2. At pi over 4, 0. Pi over 2, -1/2. 3 pi over 4, 0. And pi 1/2. This would be my one full cycle, not shifted at all. Now, I would go ahead and do my right shift before I do my up and down shift. Sometimes I'll do them all in one thing, but just for the sake of us seeing it, since it's the first one that's also gone down, I want to do it separate. So in red, I'm going to do the right 3 pi. So every point is going to the right 3 pi. So this one that's at 0 is going to 1 pi, 2 pi, 3 pi. So at 3 pi and 1/2, I have a point. And then basically, I just need to follow this down and pretend that my graph was just in this region. So at pi over 4, this would be over 1 pi, 2 pi, 3 pi. So at 3 pi and 1/4, anyways. Just thinking about it, it's kind of, it's not actually whatever 3 pi over 4 and pi over 4 would be, but anyways. So it's shifted here. And what I can do is I can think about this as me just completing the cycle in this little range here. I don't really have to actually manually move them all over, but I am just for the sake of it. This point here would be going over, basically I'm at, this is over 1 pi, this is over 2 pi, so then halfway between here, this one goes there. I know that the next point has to go up, so it would be here and then here. And so all I did was basically I just redid the points between 3 pi and 4 pi. Nothing crazy. And then I take every point and shift it down 1. Remember, I'm counting in increments of 1/2, so I just need to be mindful of that. So this point that's here, positive 1/2, is going down to negative 1/2. This point that's at 0 is going down to negative 1. This point that's at negative 1/2 is going down to negative 3/2. This point that's at 0 is going down to negative 1. And this point that's at 1/2 is going down to negative 1/2. And, just connect the dots. So this is my final graph here, shifted. So obviously, it's kind of a lot. I'm going to be honest, they don't normally shift that far over. It's normally they're overlapping in some fashion. This one's just extraordinarily far over. But anyways, any questions on those? All right, so parent function quiz tomorrow. So you don't need to worry about these tonight. After you're done with that parent function quiz, you'll have time to do these problems. I'm going to go ahead and give you the problems that go with this section as well. So this is 6.4, and we're going to do 29, 31, 33, and 35. And again, these are all the instructions of what we just did where you're actually graphing these ones. Okay, and then basically you'll have tomorrow whatever's left after your parent function quiz, which if you know those really well, shouldn't take you super long, probably 10-15 minutes tops, just because obviously it's time consuming to draw graphs. You'll have the rest of the time to do these. We'll go over them on Wednesday to make sure that we know what we're doing, make sure we've got the graphs good. I may work them out ahead of time. I may wait and do them actually in class with you. I don't know. We'll see. It'll kind of depend on where y'all are at tomorrow. We'll decide. And then after that, we'll go over tangent, which the only thing we'll be doing with tangent is stating the period and the vertical asymptotes. So that'll be 6.3, but for tangent. And then we'll be done with this stuff. So that's all we've got there. But anyways.